This is the post-lab for the Hydrate Lab for Honors Chemistry. In this post-lab, we will be determining the empirical formulas of two hydrated salts, copper 2 sulfate and calcium chloride. As you're transferring information into your lab notebook, please write out the description of each calculation and show all of your work for each problem as you're working through the post-lab questions. I'm going to model the copper 2 sulfate calculations in this post-lab video. The first calculation is sort of a check. You were supposed to measure 2 to 3 grams of the copper 2 sulfate hydrate into your test tube before you heated it. This is a check to see whether or not you had a large enough sample or not. So to do this, you take the mass of the test tube and the hydrate before heating and subtract the mass of the empty test tube. And that will give you the mass of the hydrate. The data that I have down here is from when I did the experiment, and my sample size was 2.57 grams of hydrate, which is good. It needed to be between 2 and 3 grams, and so that was a good sample size. Hopefully your sample size is within the range as well. The second step asks you to calculate the mass of the copper 2 sulfate after heating, so the mass of the anhydrous salt. So you have the mass of the test tube and the anhydrite. Afterwards, subtract the mass of the empty test tube, and that will give you the mass of the anhydrite that was left at the bottom of the test tube. So in my case here, I had a mass of anhydrite of 1.84 grams. Step number 3 has you calculating the number of moles of copper 2 sulfate, and there's a hint, you'll need to use your periodic table. So we'll start this problem with the number of grams from part 2. So I had 1.84 grams of copper 2 sulfate. In order to get the unit here to cancel, we'll need to put that unit in the bottom of the next step. So grams of copper 2 sulfate goes down here. And then what would go on top would be moles of copper 2 sulfate. And as you recall from all of our problems we've been doing, the number that goes with mole is, hopefully you said 1. And the mass that goes on the bottom comes from the periodic table, and that is 159.62 grams. All right. So then, at this point, my units of grams will cancel, and then I can calculate the number of moles of hydrate of the copper 2 sulfate. And in this case, I had 0.0115 moles of the anhydrate copper 2 sulfate. Okay, that we will use a little bit later. I rounded to 3 significant figures because the mass that we started with here only had 3 significant figures. Step 4 has us finding, well, just how much water was in this. So we have the mass of the test tube along with the copper 2 sulfate before heating, and we subtract that, the mass of the test tube and the anhydrite from after. So we take what we started with and subtract, anhydride, can't spell. So taking the mass that we started with at the beginning, subtract what we ended up with, will give us the mass of the water that was left over. In my case here, I had 0.73 grams of water that were released from the crystals in my sample. We then convert those grams of water to moles of water using the periodic table once again, only this time the mass of water, which is 18.02 grams, and then we find the number of moles of water. And in this case, I have 0.041 moles of water. What we now want to do then is write the empirical formula. So here I have CuSo4 with a subscript of 0.0115, And then remember, this hydrate is a dot here, and there's H2O times 0.041. Well, we don't leave it like this. This looks kind of silly. So what we want to do is we see, well, which one of these is the smaller of the two, and that happens to be the copper 2 sulfate. And we divide both of these numbers by 0.0115. Well, here we get 1. So we have 1 copper 2 sulfate. And then over here for the water, we end up getting 3.57, which for the purposes of this experiment, what we will do is round this up to 4. Okay, and to show that in the formula of the hydrate, rather than putting it on the outside of the parentheses on the bottom, like we typically would do for an ionic compound, since this is a hydrate, we're going to put the dot there and then 4 in front of the H2O. Okay, so that is the empirical formula of this particular compound. You'll repeat these steps for the calcium chloride in your lab notebook. And then to finish off the post-lab, there's no improvement section needed. And the conclusion, state the hydrated formulas that were determined. That's it. Thanks for watching.